everyone. I am Bindusree, working as an assistant professor in the Department of Electronics and Communication Engineering at Institute of Aeronautical Engineering. This session will discuss about the concepts of introduction to digital electronics and number system and conversion of the number systems. Before discuss about the digital electronics, so in the introduction of digital electronics are including in the signals and types of the signals and digital circuits and digital electronics. Okay, so first one is the what is the signal. So signal is a function. It is depending on the one or more independent variables. That independent variables are the either the time, space, or any other independent variable. So examples of the signals are the either the voice signal, speech signal, video signal. All the signals are including in the signal. So here we are taking the one function. So that function is the either we are taking the some f of t. So here that function is depending on the time. Okay. So in the x-axis we are taking the time. In the y-axis we are taking the, either the temperature or voltage or current, whatever it is. So this is the signal. So signal is the two types of the signals are there: analog signal and digital signal. In the analog signal, so analog signal is a continuous time signal. So it depending on the every instant, every second, it is depending on the every time. Okay. So for example, I want to measure the temperature from morning 9 to evening 6 o'clock. Okay. So in the x-axis we are taking the time. In the x-axis we are taking the time. In the y-axis we are taking the temperature. Okay. So now I want to measure the temperature from 9 to 9:30. So in the first one I will take the at 9 o'clock we will measure the some temperature. Okay, some 26 degrees centigrade. At 9 1 second. 9 o'clock 1 second also we can measure the temperature. 9 o'clock 1 second also we can measure the temperature. Okay, so as it is we can measure the temperature at 9 2. So either the temperature is the some 28 degrees centigrade. So at 9 3 we can measure the temperature also. So 9 4. So that graph is the like this. Okay, so here in the analog signal it is a continuous signal. We can measure the each and every second. So that is the analog signal. Okay, so coming to the digital signal. So it is depending on the different instant of the time. Instant of that time. For example, here also we want to measure the temperature. But here we are taking the some instant of the time. So that means either we are taking the each and every hour or every 2 hours or every 3 hours. So here we are taking the some instant of that time period. So in this x-axis we are taking the time. In the y-axis we are taking the temperature. But here we are taking the some instant of the time is the 1 hour. For example, so 9, 10, 11 and 12. So at 9 o'clock that either the temperature is the some 27 degrees centigrade. Either the 10 o'clock some 28 degrees centigrade. Either the 11 o'clock some 26 degrees centigrade. At the this one 22 degrees centigrade. In the digital signal we are taking the some discrete values. So it will be represented like a samples. So compared to the analog signal and digital signal. So compared to the analog signal and digital signal, this analog signal have the some noise compared to the digital signals. In the analog signal, we are taking the each and every second of the time. So it may be noise will be occurred. Okay. So in this digital signal, we are taking the some instant of the time period. Noise might be the reduced. So this is the analog signal is a continuous time signal. Digital signal is a discrete time signals. So next one is the digital circuits. So this digital circuit is depending on the one or two discrete values. That means either on or off condition or zeros and ones. This means indirectly this digital circuit is depending on the binary values. In these binary values we are having the zeros and ones. Either the true or false or on and off condition. So here it will be depending on the Boolean algebra. Boolean logic functions. So this is the digital circuits. So coming to the digital electronics. So in this digital electronics, if we are taking the any signal, either that signal is the speech signal or either we are taking the some songs or whatever it is. So that signal is the analog signal. That signal is the analog signal. So that analog signal will be converted to the electrical signal. For our understanding purpose, we are converting the analog to the digital signals. So if we are converting the analog to digital signal, we can reduce the noise also. So the examples of the digital electronics are the laptops, televisions, remote controls, other entertainment systems are we are using the digital electronics. That's what in our system, if you are taking the any analog signal, that will be converted to the digital signals. Okay, we can reduce the noise also. Okay, we can reduce the complex of the circuits and noise and easily understandable. So that's what we are taking the digital electronics. So in this digital electronics, mainly depending on the number system. First the concepts are the number systems. That number systems are the decimal number systems, binary number system, octal number system, and hexadecimal number system. Generally, we are calculate the any item or any value, any particular values. So in the decimal number system, so generally we are measuring the any items by using the decimal values only. So that means 0, 1, 2, 3, 4, 5 like this. So that is the decimal number system. So next one is the binary number system. In the binary number system, computer will understanding the binary values only. So that is the zeros or ones. Next, octal number system. This is also octal, hexadecimal and binary values. All the values are the computer will understanding the remaining the number system. So each and every number system we are having the some base or radix value. Each and every number system we are having the some base or radix value. So what is the base or radix? The value representing a particular number system is the base. The value representing a particular number system is the base. Okay. So for here we are taking the decimal number system. So in the decimal number system, we are taking the values from the 0, 1, 2, 3, 4, 5 like this. So up to the 9. So here the decimal number system base value is the 10. Here the decimal number system base value is the 10. So the ranging value from the 0 to 9 only. So that means if the base or radix value is denoted as R, the maximum value of this decimal number system is the R minus 1. So that means 9 only. The base value is the 10, 10 minus 1 is 9. So the maximum value of the decimal number system is the 9, the base value is the 10. Okay, so here the values are the 0, 1, 2 like this, some 9 up to the 9. Next one. So next, the binary number system. The binary number system, the base value is the 2. So here we are using the values only zeros and ones. Only the zeros and ones. The maximum value of the binary number system is 1. 2 minus 1. Okay. So next one, octal number system. Octal number system, the base value is 8. Base value is 8. The values are the 0, 1, 2, 3, 4 up to the 7. So the maximum value of the octal number system is R minus 1. R value is the 8. 8 minus 1 is the 7. Okay. Next one is hexadecimal number system. So in this hexadecimal number system, the base value is 16. The base value is 16. So in this hexadecimal number system, including the numbers as well as the alphabets also. So from the 0 to 9, the number system, A to F are the characters. Okay, the base value is the 16. So the maximum value of the hexadecimal number system is the 16 minus 1, 15. 16 minus 1, 15. So these all are the particular decimal number system base values as well as the maximum value of that particular number system. Okay. So what is the decimal number system? So what do you know about this decimal number system? We are having the base value is the in the decimal number system base value is the 10. The values from the 0 to 9. So each and every number system, it is including the real values or fractional values also. Real values or fractional values also. So if this is the one decimal value 1358. So here we are taking the weight of that particular position. So this is the first one is the first position and 10th position, 100 and 1000 positions. So like this here we are taking the 8 into 10 power 1, 5 into 10 power 8 into 10 power 0. So this value is we can write like this 8 into 10 power 0 plus 5 into 10 power 1 plus 3 into 10 power 2 plus 1 into 10 power 3. This is the weight of that particular number. So 1000 plus 300 plus 50 plus 8. So the total number is 1358. 1358. So this is the base value is 10. So this is the decimal value. So this is the integer value. So for example, we are taking the fractional value also. So that means this value is like this 1358 point some 23. So in the point right side we are taking the fraction values, point left side we are taking the integer values. That means, so in this first position we are taking the 8 into 10 power 0 plus 5 into 10 power 1 plus 3 into 10 power 2 plus 1 into 10 power. Like this, in the right side we are writing the 2 into 10 power minus 1. So that means in the right side fractional values we are writing the values multiply with the r power minus 1. So here the base value is the 10. So 10 power minus 1. So that means 2 into 10 power minus 1 plus 3 into 10 power minus 2. Like this we are taking the values in the decimal number system. Okay. So each and every number system we are having the integer values as well as the fractional values also. The point right side values we are taking the fractional values, that is the base value power minus 1, minus 2, minus 3 like this. Point left side values we are taking the r power 1, r power 2, r power 3 like this. So this is the decimal number system. Next one, binary number system. So here in the binary number system, we are having the only 2 digits, zeros and ones. The base value is the 2. The base value is the 2. So here we want to multiply the any value is from the 2 power 0, 2 power 1, 2 power 2, 2 power 3 like this. Here also fraction values are there. So that is the point right side values, that is multiply with the 2 power minus 1, 2 power minus 2, 2 power minus 3 like this. So here the binary value is the 1101. 1101. So in the first position of this value is multiply with the 2 power 0. So this is the binary value. That's what this number we are having the combination of the zeros and ones only. Okay. So 1 into 2 power 0 plus 0 into 2 power 1 plus 1 into 2 power 2 plus 1 into 2 power 3. Okay, in this first position is multiply with the 2 power 0. Second position is multiply with the 2 power 1. Third position is multiply with the 2 power 2. Fourth position is multiply with the 2 power 3. So why? Because so here we are taking the values from the 0 to some 3. So 2 power 3 is 8. 2 power 2 is 4. 2 power 1 is 2. Multiply with the 0, 0. 2 power 0 is 1. So the value is 13. The value is 13. So this is the decimal value. So This is the decimal value. The base value is the 10. The base value is the 10. Okay. So this is for the integer value of the binary values. Now I want to take the fractional values also. So the example of this one is 1101.10. Okay. In the point right side we are taking the fractional values. Point left side we are taking the integer values. That means we are multiplying with the minus values in the right side, multiplying with the positive values in the left side. Okay. So in the right side, first we are taking the left side of the values. 1 into 2 power 0, 0 into 2 power 1, plus 1 into 2 power 2, plus 1 into 2 power 3. In the right side, we are taking the 1 into 2 power minus 1, plus 0 into 2 power minus 2. 8 plus 4 plus 0 plus 1. 2 power minus 1. So that is the 1 by 2 plus 0 into 1 by 4. Value is the 0. So here the value is 13. 1 by 2 is the 0.5. So the value is the 13.5. If you are taking the any binary number system, we are taking the values like this. Okay, this is the binary number system. Next one is octal number system. So here the base of octal number system base value is the 8. We are using the digits from the 0 to 7. 0, 1, 2, 3, 4, 5, 6, 7. The maximum value of the octal number system is the 7. So here also we are taking the any value. So that value, for example, we are taking the only integer value. So that values are multiplied with the base value with the powers from the right side to the left side. In the first bit position, we are multiplying with the base value of the power 0. Okay. Second bit position, multiply with the base value of the power 1. Next value is multiply with the next base value power 2, like this. Okay. So here we are taking the octal number is 1457. Okay. So in the first bit of this position is 7. So in the octal number system base value is the 8. So 7 into 8 power 0 plus 5 into 8 power 1 plus 4 into 8 power 2 plus 1 into 8 power 3. Okay. So here multiply with the 8 power 0 is the 1, 7, 8 5s are 40 plus 64 into 4, 256. Okay, 64 into 8, 32. 64 into 8, 5, 12. So now adding these values. So 5, 12 plus 256 plus 40 plus 7. So 47 plus 6 plus 2, 8, 8 plus 7, 15, 5, 10, 11, 8, 15. 8, 15. So if you are taking this is for the integer value of the octal number system. So for example, we are taking another number system 23.12. 23.12. In the point right side, we are taking the positive 2 values. In the point left side, we are taking the 2 values. So in this right side of the values are multiplied with the base value power the minus 1. So 1 into 8 power minus 1 plus 2 into 8 power minus 2. The left side 3 into 8 power 0, 2 into 8 power 1. 16 plus 3, 1 by 8 plus 2 into 1 by 64. Okay, 19 plus 2 by 32. So here we are having some fractional values. This is the octal number system. So next one is the hexadecimal number system. In this hexadecimal number system, base value is the 16. The digits from the 0 to 15. From 0 to 9, we are taking the numbers. A to F, we are taking the characters. So that means in the A value is the 10, B is 11, C 12, D 13, E 14, F is the 15. From the 0 to 9, the number values. Next one, A to F are the characters. So A equal to 10, B equal to 11, C equal to 12, D equal to 13, E equal to 14, F equal to 15. Here also same procedure. If you are taking the integer values, that first position will multiply with the base value power the 0. Second position multiply with the base value power of the 1 like this. So here we are taking the value is 1805. In the first bit of this position 5, the hexadecimal number base value is the 16. The power is 0. Next one is 0 into 16 power 1. Next one is A into 16 power 2 plus 1 into 16 power 2. Okay. So multiply with the 16 power 3, 16 power 2, 16 power 16 power 0. So if we are taking the any values in the integer, so integer as well as the fractional values. So 12.01. So in the left side of the values, here multiply the 16 power 1, 1 into 16 power 2. In the right side, 16 power minus 1 plus 1 into 16 power minus 2. Okay, so 256 plus 32 minus, multiply with the 0, 0 plus 1 by 256. That is the final value. So this is the procedure for either the integer values or fractional values, how we are multiply with the base values. So this is the procedure for the all the number systems. Okay, so each and every number system we are having the integer values or fractional values. First we have to take the position depending on that position. So the if we are taking the integer values, that position is multiplied with the base value of the power 0. If you are taking the fractional values also, in the point right side values are multiplied with the base value power the minus 1. Same procedure will follow for the all the number system values. So next topic is the conversion of the number system. Conversions of the number systems. So why we are going to the conversion of the number systems? Generally, we want to book the ticket, either the bus ticket or movie ticket, whatever it is. Now I want to book the tickets only for 2 members or 3 members. Okay. Now we are entering the value is the sum 3. But computer will understanding the binary values only. Now I want to book the ticket by using the computers. Okay. Generally, we are using the decimal system, decimal number system only. Now I want to book the ticket. So generally we are giving the value is 3. But computer will not understand that value. So that's what we are converting the decimal value is binary value. That's what we are converting the decimal to binary value. Okay. So now computer will converting that 3 value is converted to the binary value and book the ticket. Okay. So this is the one example why we are using the conversions. Why we are using the conversions. So that's what we want to convert the decimal number system to the binary number system as well as the octal and hexadecimal number system. Okay. So binary number system, computer will understand the binary number system only, but human being will understand only the decimal number system. Again, we are converting the binary values to the decimal number system. So that's what we are using the conversions. Okay. So now I want to convert the any number system, either division of that particular division of that value by using the base, or multiply of that value by using the base values only. So either that is the base or radix. Now I want to convert the decimal number system to the binary number system. That means if you are taking the any value, so now I want to convert the decimal to the binary. Decimal to the binary. Okay. So we are taking the any value, that is the decimal value. So now I want to convert the binary. The base value is the 2. The base value is the 2. Now we want to divide with the value with the base. The value is divided with the base value 2. So the remainder value is noted in this one only. Okay. So again we are dividing with the base value. Again we are writing the remainder value. Okay. So this procedure will continue till the 0. So now I want to write the resultant value from bottom to right, bottom to top. This is the procedure for decimal to the any other number system, not only the base, octal or hexadecimal number system. Okay, now we are taking the any base, any number value. So whatever the we are taking that value based on that number system, we are taking the base value. So divide the base value of that particular number system, note the remainder value. Till the procedure will continue last 0 values. So after that we are writing the result from the bottom to top. Okay. So first one is the decimal to binary number system. Okay. So here we are taking the value with some 24. 24 base 10. Now I want to convert that decimal value to the binary. Okay. So this binary base value is the 2. So first we are taking the 2 by 24. Okay. So 12, the remainder value is the 0. Again we are divide with the 2 value, 6 times again 0. So next one, divide with the 2, 3 value 0. So next one, 2 1 are 2. So the remainder value is the 1. The remainder value is the 1. Now we are writing the resultant from the bottom to top. Means 1 1 0. So this is the base. This is the procedure for converting the decimal to the binary value. So here we are taking the sum 24.12. This is the one base value. Now I want to convert the binary system. Okay. So in this point left side value is there. So this value is divided with the base value. Point right side value is there. So this value is multiplied with the base value. Okay. So if you are taking the any decimal value, so the decimal value is including the integer and fractional value. So point's left side value is divided with the 2. Point right side value is multiplied with the 2. So the procedure is, first we are taking the point left side value 24. So same procedure, divide with the 2, 12 and 0. So 6, 0, 3, 0, 1. Okay. So this value, the resultant value is right from the bottom to top, 1, 1, 0, 0, 0. So now we are having the point right side value is there. So 0.12 is multiply with the 2. Multiply with the 2. So here we are getting the 4, 2 and 0. 0.24 is there. So again 0.24 into 2. 0.840. Okay. Again we are taking the value 0.48 into 16, 5, 0.5. Okay. Again 0.56 into 2, 12, 11, 1.12. Again we are having the 0.12 into 2. So the same value is repeating. So now we have stopped this multiply of these values. Okay. Now we are writing the resultant value from the top to bottom. Whenever we are multiplying the base value, the resultant values are writing from the top to bottom. So now the value is 0001. What is the complete of this value? The point left side we are getting the 11000 point. In the point right side 0001. This is the conversion of the decimal to binary by using the fractional values. For suppose if you are not repeating the any value, so after 4 to 5 multiplications we can stop that. So if you are repeating, we are stop that one. So if this is not repeating the if it is not repeating the any values, so after the 4 to 5 multiplication we can stop that. So this is the decimal to binary number system. Next one, decimal to octal number system. Same procedure. So in the decimal to octal number system also. Okay, so here also depending on the octal base value. Here also we are taking the octal base value. So in the integer value we are dividing with that base value. If you are taking the fraction value, point left side we are dividing with that base value, point right side we are multiply with the base value. So first we are taking the some base value, some 84 base 10. Now I want to convert this one into octal number system. So decimal to octal. Decimal base value is 10, octal base value is 8. So now the base value is 8. Divide with this 8. Okay. So 8 tens 80. So the remainder value is 4. Okay. Next one, 8 ones are 8. The value is 2. The remaining value is 2. So now I want to write the resultant value. Now I want to write the resultant value. So we can write the resultant value from the bottom to top. So the value is 124. 124. This is the yes. Okay. So same one. If you are taking the 84.11, the base value is 10. So now I want to convert this decimal value to this octal number system. So same procedure. In the point left side values are divided with the 8, point right side values are multiply with this 8. So already we know point left side values we are multiply with the 8, we are getting the 124. Now we are having the values only the point right sided values. So that is 0.11 into 8. So 8 into 0. So again we are taking the 0.88 into 8. 64 plus 670. So some 704. So again we are taking the 04 into 8. Again 0.32 into 8. 2.56. Again 0.56 into 8. 48, 44, 4. So now we can stop these values. So we are getting the resultant value. How can we are writing the resultant value from the top to bottom? So 07024. The final value is 124.0702. So this is the procedure for converting the decimal to octal number system. Next one is the decimal to hexadecimal number system. In this decimal to hexadecimal number system also same procedure. So here we are taking the value some 156. The base value is 10. Now I want to convert this value into the base 16. So here we are taking the only integer value. So 16 divided by 150. So is it possible? No. 9 times I think so. 92. So the base value is the 92. Okay. So if for example we are taking the integer values also, integer and fraction values also. How can we are converting this one, ma? This one, sorry. So in the left side value we are divided with the 16. In the right side value we are multiply with the 16. 0, 1, 1 into 16. 16. 1.76, 0.11 into 16. Okay. Again 0.76 into 16. 96. 96 on 129. 121. So 12 is there. So 12 in the hexadecimal 12 value is, we can write after that we can write. So 16 like this. In this 12 hexadecimal value is some A equal to 10, B equal to 11, C equal to 12. Okay. So here we are writing the value. The resultant value we are writing from the top to bottom. So 1, the 12 value is the C. Here we are converting the decimal to hexadecimal value. So that's what here we are taking the alphabet. Okay. The C value is the 12. So the value is the final value is 92.16. 92.16. So this is the procedure for converting the decimal number systems to all other number system. Okay. So next one is binary to other number system. Binary number system to the other number system. So first one is the in the binary to the decimal conversion. Binary to the decimal conversion. So in this binary to the decimal conversion, we are multiplying the values with respect to the position of that weights. So this is the decimal value 1101. So now I want to convert this value to the decimal. Okay. So already we discussed about this topic in the conversion in the number system. So in this, depending on the weight of these positions, so we are multiply that values. After that we are adding the all the values, we are getting the resultant value. So in this first position we are taking the 2 power 0. Second position we are taking the 2 power 1. In the third position we are taking the 2 power 2. In that next position 2 power 3. So 8. Okay. 4 plus 0 plus 1. Okay. So adding these all the values, we are getting the 13. So this is the base value. Okay. Similarly, already we discussed this one 1 0. So in the left side we are multiplying with the 2 power 0. In the right side 1 into 2 power minus 1 plus 0 into 2 power minus 2. So 1 into 1 by 2. So 0 multiply with the any value, we are getting the 0. So this is the 0.5. So the final value is the 13.5. This is the binary to other binary to the decimal number system. So next conversion is the binary to the octal conversion. Okay. So in the octal number system, the base value is the 8. We are taking the values from the 0 to 7. That means, so here we are using the number of bits are 3 only. Number of bits are 3 only. Okay. Number of bits are 3 only. In the binary to the octal number system, whatever the binary value we are taking, we are dividing the 3 bits only. First step is we are dividing the 3 bits only. Then we are writing the equivalent values. Okay. Means 1011, some 0101 is there. Okay. So now I want to divide this binary value in the 3 bits. So from the right to left, we are dividing the 3 bits. From this right to left. Okay. In this first we are separating these 3 bits. Again we are separating next 3 bits. Okay. So next we are having the only 2 bits. So again we are adding the 0. So now I want to write the equivalent binary value. So that is the 1015. 110 is 6. So 265 is the resultant value. So this is the binary value. This is the equivalent octal number system. Okay. So next example. We are taking the next example 101101 point some 10101 is there. So in this point left side of the values, either the point right side or point left side, we are dividing with the 3 bits only. Why? Because in the octal number system we are having the from the 0 to 7. So the number of bits, we are using the number of bits only 3. So in this point left side we are separating the 3 bits, again separating the 3 bits. Coming to the point right side. So here also we are separating from the right to. So this position. So in this one right to this position. So here we are separating this position. So separating the 3 bits. So here also we are having the only 2 bits is there, adding the 0. Now we are writing the values. 5, 5, 2, 5, 2. So the equivalent value is the 255.52. So in the binary to the octal number system, based on the number of bits, we are separating the values, we are writing the resultant value. If that number of the value is not equal to the 3, means either the 1 is there or the 2 is there, we are adding the zeros. Okay, this is the binary to the octal conversion. Next one is binary to the hexadecimal conversion. So in this binary to the hexadecimal conversion, so here the hexadecimal base value is 16. So 16, the 2 power 4 equal to 6. So here we are using the number of bits is 4 only. Number of bits is 4 only. Okay. So here we are separating that binary value is 4 bits only. That is the hexadecimal number system. So for example, 1 is there. So this is the binary value. Now I want to convert this binary value to the hexadecimal value. So now form a one group for by using the 4 bits, separating the each and every 4 bits. So from the first position to the last position, means from the LSB to the MSB. Okay, LSB is the least significant bit. So first separating the first 4 bits. Okay, next separating this next 4 bits. Okay, so this value is equal to this 6. This value is equal to this 5. Next value is equal to this B. Okay, B 5 6. B 5 6. Okay, so 1010 is the 8. 1011 is the B. So that's what B 5 6. So next value is. Next example is, so here we are taking the only integer values only. So for example, we are taking the fractional values also is there. So in this point, left side or right side, we are separating the 4 bits is form a one group. Okay, this 4 bits and this 4 bits. So here we are having the only 3 bits is there. So 3, adding the zeros. So in the coming to the right side, we are starting from the this position to the separating the 4 bits. So here this is the one group, and next one we are having the only 2 bits are there. So again adding the zeros. Now writing the equivalent binary values. 5, B, 2, again this is the B and 4. So the equivalent value is 2B5 point B base 60. This is the binary to the hexadecimal conversion. Next one is octal to decimal conversion. Octal to decimal conversion. So in this octal to decimal conversion, so what is the procedure of this one? First, multiplying the digits of octal number system with respect to the positional weights. So in this octal number system is the sum 263. Sum 263. So now I want to convert this octal number system to the binary values. So from the decimal to remaining other number systems, divide with the base value. So remaining other number system to the decimal values, multiply with that values. So 3 into 8 power 0 plus 6 into 8 power 1 plus 2 into 8 power 64 into 2, 128 plus 48 plus 8 power 0, 1 plus 3, 19, 179 base 10. Okay. So here the maximum value is the 9. So in this decimal value, adding this value. So in this next example, 263.10. So this is the octal value. Now we are converting this octal to the decimal value. So already here in the left side, we are multiplying the 8 power 0, 8 power 1, 8 power 2. So in this right side, 8 power minus 1 plus 0 into 8 power minus 2. Okay. So 1 by 8 plus 0. Finally 179.25 base 10. This is the octal to decimal conversion. So next one is the octal to binary conversion. So in this octal to binary conversion, this octal base value is the 8, separating the 3 bits only. Okay, here the value is the octal value is the 145.23. So now we are writing the equivalent binary values using the only 3 bits. Okay, so in this first position 5 is there, 5 equivalent binary value using the 3 bits only, that is the 101. So next one is 4 equivalent binary value is, next equivalent binary value is 4 using the 3 bits 100. Next one value is 001 point. So in this 2 equivalent value is 010, 3 equivalent value is 01. So this is the octal to binary conversion. So whatever the value we are taking, so separating, writing the 3 bits, by using the 3 bits we are writing the binary value. So this is the octal to binary conversion. Next one is the octal to hexadecimal conversion. Okay. First one, we are converting the, so now I want to convert the octal to hexadecimal number system. Follow the 2 steps. First, write the octal number system to the binary number system. Next step, we are converting that binary to the hexadecimal number system. First, write the octal to binary number system. So in this octal to binary number system, so here we are using the octal values only. We are separating, we are writing the binary value using the 3 bits. Okay. So for this 1, 001, for 4, 100, for 5, 101. Okay. For 2, 010, for 3, 011. So this is the first step. For this octal number system is converted to the binary. So next one, this binary value is converted to the hexadecimal number system. Okay. Now separating the 4. Okay. So from the right to left. So this 4 is the one group and this 4 is the one group. So next one, in the right side, this 4 is the one group and this 4 is the one group. Okay, 0101, 01106, 0.4, 1100. 110 is equivalent value is 1010 is the A, 1011. So this is the D. Okay. So now value is the 65.4. Sorry, this value is the C. 4, 7. This is the hexadecimal number system. So in this octal to hexadecimal conversion, first we are converting the octal number system to the binary value. Again, that binary value will be converted to the hexadecimal number system. Similarly, in the hexadecimal number system to the remaining conversions. In this hexadecimal number to the remaining conversions, already we know this procedure. So in this left side, we are multiply with the 16 power 0 and A into 16 power 1 plus 1 into 16 power 2. In the right side, 2 into 16 power minus 1. So we are getting the binary decimal value. Okay. So after multiplying these values, sum of these all the values, we are getting the resultant value. Next one is hexadecimal to binary conversion. Hexadecimal to binary conversion. So now we are in this hexadecimal number, base value is the 16. So the number of bits are the 4. By using the 4 bits, we are writing the equivalent binary values. Okay. For this 60110. For this 50101 point. For 40100. For C 1010101100. So this is the binary value. Okay. This is the conversion for the hexadecimal to binary value. So hexadecimal base value is the 16. Here we are using the number of bits are 4. That's what we are writing the binary values using the 4 bits only. So next one is the hexadecimal to octal number system. Here also same procedure. So in this first one is the convert the hexadecimal number to the binary number system. Second one, convert the binary number system to the hexadecimal number. Okay. Sorry, convert the binary value to the octal number system. In this first step, we are writing the equivalent binary values. Okay, by using the 4 bits 0, 1, 1, 0. Next one is 0, 1, 0, 1 point 0, 1, 0, 0 1, 1, 0, 0. Okay, now I want to convert the octal number system. In this octal number system, using the 3 bits only. So separating the 3 bits. Okay, so in the left side we are separating this 3 is the one group and this one is the one group. So here we are having the only 2 bits only, adding the 1 more bit. In the right side, again we are separating the 4 groups. Okay, sorry. Here we want to convert this octal number system, separating the 3 bits only. 0, 1, 0, 0, 1, 1, 0, 0, 0. Okay. 5, 4, 1. So this value is the 2, 3, 0. So 145.230. Octal number system. Okay. So first convert the hexadecimal to the binary number system. Second one, convert the binary number system to the octal. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.